Hi, this is Mumasankar, All India IIT Coordinator. Hi my friends, through our channel actually we are covering several topics in mathematics. Recently we have completed the detailed lesson of complex number, which is very important for JEE Mains, Advanced and board examinations also. After complex numbers, the immediate important topic is vector algebra. Actually, here in vector algebra, I have divided the entire vector algebra into nearly 20 to 25 lessons. Today, this is lesson 1 I am concentrating. Through this lesson 1, I am particularly concentrating on properties of vectors. If you are mastered this properties of vectors, then you will get complete idea when to and where to apply the properties and the applications of the properties confidently. So, in this lesson here I would like to concentrate on these few topics. What are those? Basic definitions and notations, and collinear and coplanar vectors, vector addition, scalar multiplication of a vector, and section formula, angle between two vectors. These 5 areas I am covering through this video or through this lesson, lesson number 1. And here my friends, of course in vector algebra, if we are concentrating exclusively on definitions alone, it may take lot of time. That is why today here through this lesson, I am just giving the most useful definitions of the vector algebra. If you have mastered these definitions alone, that's sufficient and that serves your regular purpose. With help of this information, you can do wonders. You can do the best in board examinations as well as mains and advanced examination problems also. Okay, now coming to the basic definitions. Of that, now this is the definition of a vector. See, what is a vector? Everybody knows it, because here I am not giving the definition again and again. Simply, it is a quantity having both magnitude and direction. This is important. This is the quantity having both magnitude and direction. So, any quantity which having magnitude and direction is called a vector. In general, it is denoted with AB bar. Suppose this is vector AB bar. Here this point A is called initial point, and B is called terminal point or final point. Terminal point or final point. So, basically if anybody wants to learn something in the vectors, one should know the basic information like this. So, here A is called what? Initial point, and B is called what? The terminal point. B is called what? The terminal point. And the magnitude of the vector is denoted by mod AB bar, and simply we can also write it as AB. So, see the difference between these two. Here I have represented AB bar in between the modulus bracket, whereas here there is no bracket and there is no vector notation on that. So, here whenever I am representing A to B, it indicates what? The vector is starting from A and ends with B. This is what? Indirectly, in general what? It is what? A directed line segment. It is a directed line segment. Suppose this is a line and this is a vector, this is a point A and this is a point B. This is called a directed line segment, a segment, line segment. So, for a segment, it has some length, that is called magnitude. If I have given the direction from A to B, then only it becomes what? A vector. That is why this point A is called initial point, and this point B is called what? Terminal point or final point. Terminal point or final point. Okay? This is one basic definition of the vector. Of course, several examples will be there. You might have learned all those things in your physics classes also. Now, coming to zero vector. Next important definition is zero vector. So, the zero vector is, it is also a vector having magnitude 0. So, in general, the zero vector is denoted by O bar or O bar, like this. We can represent. And magnitude of zero vector is 0. It is number. Magnitude is always a number. It is any number, real number. Okay. So, the vector is represented like this. So, see see the definition, a vector of 0 magnitude which has the same initial and terminal point. Moreover, for 0 vector there is no distinguish, we never distinguish between initial and terminal point, both are same. Whenever initial and terminal final points are coincide to each other, then only the vector becomes what? 0 vector. That means if A equal to B or if B comes to A, then automatically it becomes a what? A point. So, any direction for 0 vector it has infinitely many number of directions, but a magnitude is what? Absolutely a 0. Now, coming to my friends, next unit vector. This is one of the important definition in entire vector algebra. Several problems are depending upon this unit vector. Suppose if A bar is any vector, in general vectors are denoted with capital letters or small letters like this. Suppose if A bar is any vector, then mod A bar is called its magnitude. Then A bar by mod A bar, this is called unit vector of A bar along the direction of A bar, and in general it is denoted with what? A cap. This is the symbol that I have given here. See, a unit vector is a vector of unit magnitude. Moreover, magnitude of this vector is nothing but 1, because if I have taken mod A cap, that is modulus of A bar by mod A bar, this is nothing but mod A bar by mod A bar. This is nothing but after cancellation you will get 1. That is why modulus of the unit vector is always equal to 1. This is very, very important point. And here this A cap, it is what? Along A bar. This is very, very important. Okay, this is the unit vector along A bar, we can say. Now, coming to equal vectors. Two vectors are said to be equal. So, whenever we can say the two vectors are equal, its definition itself says that in direction point of view as well as magnitude point of view, if two vectors are equal, then we can say that the vectors are called equal vectors. That means, say for example, this is AB, this is A and this is B. This is vector AB. And suppose say this is another C and this is D. This is vector CD. And length of AB is 10 units. Similarly, length of CD also 10 units, say for example. And AB, so direction of AB bar is like this and direction of CD are also like this. So, for these two vectors, direction is same as well as magnitude is same. So, AB bar is equal to CD bar, I can say simply. So, whenever this kind of conditions are satisfied by the vectors, then we can say that the vectors are what? Equal vectors. So, two vectors are said to be equal if they have the same magnitude direction, represented the same physical quantity. Clear? Now, coming to another definition, collinear vectors. Yes, this is again very, very important definition in the entire vector algebra after unit vector. What do you mean by collinear vectors? Two vectors are said to be collinear if their directed line segments are parallel. So, be careful about this one. Directed line segments are parallel. Here, not line segment, directed line segments are parallel. Disregards to their direction. Disregards to their direction. And we can also say that collinear vectors are parallel vectors. Collinear vectors are also called parallel vectors. If they have same direction, simply we can say that the vectors are like vectors. If they have opposite direction, then immediately we can say that the vectors are unlike vectors. Say for example, this is vector AB. See the direction. And this is vector CD. So, these two vectors are said to be collinear if they have same direction and what? Not only direction and what I said, directed line segments are parallel and they are moreover parallel to each other. That means the distance between these two vectors wherever you go always same, or sometimes like this. Suppose this is that line segment, suppose this is A and suppose this is C, suppose this is B and suppose this is D. This is vector AB and this is vector CD. So, here vector AB and vector CD, they lie on a line only, but Though as per line segments point of view, they represented two vectors, but they lie on the same line. Therefore, we can also call it as what? Collinear vectors. Collinear means they lie on a same line or they are parallel to each other. Okay? And moreover, if the directions of both the vectors are same, then we can say that the vectors are what? Like vectors. Otherwise, the vectors are what? Unlike vectors. Since direction of AB is this one and direction of CD is also like this, therefore, AB is parallel, AB is collinear to CD bar, or we can say that AB and CD are like vectors. Sometimes, of course, if suppose the direction of DC is like this, then we can say that the vectors are what? Unlike vectors. Okay. Now, my friends, symbolically, if any non-zero vectors, two non-zero vectors A bar and B bar are collinear if and only if one is a scalar multiple of another, where k is any real number. This is very, very important. So, whenever two vectors are said to be collinear, this condition is applicable and useful for solving the problems. So, if they are asking, anybody is asking to find whether the given vectors are collinear or not, or parallel or not, then immediately we can say that the vectors, if one vector is a scalar multiple of another vector, then it's automatically the vectors are what? Collinear, and this is a very, very important condition for solving the problems. Now, my friends, next coming to coplanar vectors. Yeah, collinear vectors means they lie on the same line and direction, and of course, they may be parallel. Whereas coplanar, if the vectors are lie on the same plane, coplanar means same plane, they lie on the same plane. Listen, read the definition very carefully. Coplanar vectors, a given number of vectors are called coplanar if their line segments are parallel to the same plane. Say, for example, this is the plane. For example, this is the plane. Say, suppose this is the vector. This is parallel to this plane. And suppose this is the vector. This is the parallel to this plane. And suppose this is the vector. And this is parallel to this plane. This is the line segment of this vector. This is the corresponding line segment. And this is if these line segments lie on this plane, simply we can say that the vectors are what? Coplanar. My friends, whenever we are talking about two vectors, they are always what? Coplanar. So, whenever we are talking about two vectors, the best question would be whether they are collinear or not is correct, because always they are what? Coplanar. Not necessary to check the vectors are coplanar or not. Only if two vectors are given, whether they lie on the same line segment, directed line segment or not, that is the only important area one should verify. So, this is about coplanar vectors, and we will practice more about coplanar vectors in the next classes. Okay. Now, coming to position vector. This is another important definition of the vector algebra. Position vector. Suppose let O be the fixed point or origin, I can say. Instead of fixed point, I can also use it as what? Origin. Then the position vector of a point P is denoted by OP bar. Say, for example, this is my x axis, y axis and z axis. These are my x axis, y axis and z axis. And suppose this is my point P and O is origin. Then this is a segment OP and this is vector OP. Then simply this vector OP, and of course it has some magnitude. Then this vector OP is called what? Position vector of the point P with respect to O. So that O must be what? A fixed point. That may be either the origin or some other point also. With respect to some other point also we can say. Suppose if A is a fixed point, then position vector of the point P is denoted with what? AP bar. Suppose if my x is any fixed point, then position vector of the point P is denoted with what? XP bar or XP bar, like this we can represent. So, like this. Suppose if A bar and B bar are position vectors of 2 points A and B, that means OA bar equal to A bar and OB bar equal to B bar, then vector AB bar is equal to OB bar minus OA bar. This is nothing but B bar minus A bar. So, if you know the position vectors of any two particular points, then the vector which passing through the 2 points is simply denoted with AB bar, and it is defined like this. So, AB bar is equal to what? Position vector of B bar minus position vector of A bar. Suppose CD bar is given for you, then what is CD bar? Position vector of D minus position vector of C. So, if position vector of D is small d bar and position vector of C is small c bar, then automatically it becomes what? D bar minus C bar. This is about what? Position vectors. Now, my friends, vector addition. What is a vector addition? How can we add vector addition? The same thing we have discussed in the complex numbers also. Why I am immediately concentrating on vector algebra? Because if you have mastered complex numbers and vector algebra, several applications are almost similar to one another. That's why vector algebra and the applications of vector algebra we may use, or the concepts of vector algebra we can utilize or use in solving the problems of complex numbers. Simultaneously, the knowledge of the complex number sometimes very useful in solving the problems of the vector algebra also. So, here my friends, vector addition. Suppose A bar and B bar are represented with OA bar and OB bar. That means position vector of A bar is OA bar, position vector of B bar is equal to B bar. And the sum A bar plus B bar is denoted with what? OC bar. What is OC bar? It is nothing but a diagonal of OACB. See here, suppose this is my OA bar. Say this is A bar and this is my OC bar, OB bar. Say this is B bar. Then just you consider these are the adjacent sides of the parallelogram, and you complete the remaining parallelogram and join the diagonal, corners O and D, O and C. Then OC bar, this is what? Diagonal of the parallelogram OACD, OACB. Then here OC bar indicates what? A bar plus B bar. So, the geometrical representation of addition of two vectors is nothing but, if you have considered the two vectors are the adjacent sides of the parallelogram, then a diagonal of the parallelogram represents addition of the two vectors A bar and B bar. So, if you are in a position to visualize the addition, then we may solve, or we can utilize that, we can get the maximum confidence on notion of the addition of the vectors. Okay, my friend? See here, suppose this is O, A, B, C and A bar, B bar, C bar. So, this is A bar plus B bar. Now, my friends, actually vector addition is commutative. These are the elementary properties of the vectors. Just like in algebra, even in vectors also we can do like this. So, A bar plus B bar is also nothing but B bar plus A bar, and vector addition is also associative. So, A bar plus B bar plus C bar is equal to A bar plus B bar plus C bar. We can also say that addition of the vectors is what? Associative. And whenever we are adding a null vector to the given vector, then the vector comes. So, if we are adding 0 bar, that means 0 vector to any vector, the same vector will come. Whenever a vector is adding to a particular vector, if the vector appears, the same vector comes, then the vector is called 0 vector or additive identity, or simply what is additive identity in vector algebra means that is 0 vector, 0 bar. Similarly, if I am adding negative of the vector A bar plus minus A bar, then automatically it becomes what? 0 bar. What is minus A bar? Suppose this is my A bar, this is my A bar, then minus A bar is nothing but same magnitude but direction is in opposite. So, these are the basic properties of vectors. Now, coming to my friends, multiplication of a vector by a scalar. So, if A bar and B bar are two vectors and M and N are scalars, then first property is, if you have multiplied the vector with a scalar M, that is also nothing but A bar into M, ultimately it comes what? MA bar. Similarly, if NA bar, this is a scalar multiple of a vector, if you have multiplied this with another scalar M, ultimately you will get what? MNA bar. Similarly, M plus N into A bar is equal to MA bar plus NB bar. Similarly, M into A bar plus B bar equal to MA bar plus NB bar. These are all are what? Additional properties of multiplication of the vectors by scalars. Because whenever we are solving the problems in vectors, these properties are always useful and helpful for you. Okay? That's why here the basic information only I am giving. Now section formula. What is section formula? In general, in coordinate geometry, suppose if A is a point having coordinates x1, y1 and B is a point having coordinates x2, y2. Suppose if a point P which divides the line segment joining the points AB in the ratio L is to M, then coordinates of point P is given by Lx2 plus Mx1 by L plus M, comma Ly2 plus My1 by L plus M. This is the section formula in what? Two-dimensional geometry. The same thing here also applicable in vector algebra. Suppose this is the line segment and position vector of A is A bar and position vector of the point B is B bar. Of course, whenever I am talking about position vectors, I am taking the fixed point which is my origin. So, this is position vector of A and this is position vector of B. So, this is A bar and this is B bar. Suppose this is P, let it be R bar say. Then and if P divides the line segment joining AB in the ratio L is to M, then what is position vector of the point OP bar? That is nothing but R bar is equal to same LB bar plus this MA bar by L plus M. See here only the notation matters. Actually you are familiar with this concept in section formula in our two-dimensional geometry. Even we have discussed the same thing in complex numbers also. The same thing here I am applying in vector algebra. Here what kind of notations that I have applied is the matter. So practice this. See here my friends, here what I am using is what is if A bar and B bar are two vectors, if A bar and B bar are position vectors of 2 points A and B, then the position vector of a point which divides AB in the ratio M is to N. See, try to understand the language. The position vector of the point which divides AB, this is line segment AB, okay, in the ratio M is to N or L is to M, whatever it may be. That is nothing but what? NA bar plus MB bar by L plus M or M plus N, and where M plus N not equal to 0. And of course, if M is equal to N, automatically the point becomes what? Midpoint. Therefore, position vector of the midpoint AB equal to A bar plus B bar by 2. This is again a very important formula for solving several problems in vector algebra. These concepts are very useful for you. Okay, my friends. Now, coming to the most important area in a vectors. Even I am very much concentrated on what? Angle between two complex numbers. Just like complex numbers, even in a vector also, angle between two vectors, the two non-zero vectors. So, whenever we are talking about angle between two vectors, the two vectors must be what? Non-zero vectors only. If any one of them is zero vector, then angle is not defined. That is the fundamental point. So, heading itself what? Angle between two non-zero vectors. How can we define? Suppose if A bar and B bar are any two non-zero vectors, then angle between A bar and B bar is denoted with, see the bracket, open bracket I am writing, interval like A bar comma B bar. How I am writing? This is very important. Okay, this is notation only. How can we define? That is important. See here, let A bar, B bar are two non-zero vectors. Let's say for example, A bar equal to OA bar and B bar equal to OB bar. Then which does not exceed 180 degrees. That's very important. It is called the angle between A bar and B bar. It is denoted by like this. So, whenever this notation appears in vector algebra, immediately you understand that this is the concept of angle between two vectors A bar and B bar. And the angle between A bar and B bar is what? Suppose the angle between A bar and B bar is equal to say some theta. Theta never exceeds what? 180 degrees. That means what? 0 less than or equal to theta less than 180 degrees only. It never exceeds. So, that is very important. Okay? But that diagram point of view, how I am representing and what kind of angles that we can differentiate between the vectors having same direction and opposite direction, that I will explain here. See, if A bar and B bar is a 0 vector, any one of A bar and B bar is a 0 vector, then angle between A bar and B bar is not defined. Okay, my friends? See, similarly, if A bar equal to OA bar, B bar equal to OB bar are two non-zero vectors, then angle between A bar and B bar is defined as the smaller angle here. Please try to understand. Here A bar and B bar are two non-zero vectors, then angle between A bar and B bar is defined as what? The smaller angle between OA bar and OB bar. This is important. See, in diagram point of view, I am giving this information for you. See, listen. So, my friends, here suppose this is origin and this is my OA bar and this is my OB bar and this is the angle between A bar and B bar. So, if it is theta, then angle between A bar and B bar is theta. Angle between A bar, B bar is nothing but angle between B bar, A bar. Both are equal to what? Theta. So, whenever I am talking about angle between A bar and B bar, that is also equal to angle between B bar and A bar, which is theta. But here, see the difference between angle between B bar and minus A bar. Here, angle between A bar and minus B bar. Here, angle between minus B bar and minus A bar. So, with this diagram, what we are understanding is angle between A bar and B bar is nothing but angle between B bar and A bar, nothing but theta. Whereas angle between A bar and minus B bar is pi minus theta. Angle between A bar and B bar is equal to angle between minus A bar comma B bar, which is equal to 180 minus angle between A bar comma B bar. Clear? And moreover, angle between MA bar comma NB bar is equal to angle between A bar comma B bar. These are the basic properties of angle between two non-zero vectors. So, angle between A bar B bar is nothing but angle between B bar A bar. Angle between A bar B bar is equal to angle between minus A bar comma minus B bar. Okay. So, angle between A bar comma minus A bar comma B bar is nothing but what? 180 degrees minus angle between A bar comma B bar. This is important. This is important. Angle between minus A bar comma B bar is equal to 180 degrees minus angle between A bar comma B bar. See the diagram, that's why. That's why here I have represented this like this. Okay, my friends. Now, this is about what? Angle between two vectors and basic definitions of the vectors, and here only basic definitions and important definitions which are very, very useful in vectors only I have concentrated. If you like this video, please share and subscribe my channel, and please don't forget to press the bell icon, and continuous lessons in vector algebra you will get it in next classes. Okay, my friends, thank you.